Which of the following IP addresses are on the same subnet? I'm going to show you two ways to solve this problem. The first way is my preferred method. Here we have 192.168.55.60.63 and .65. Someone took 192.168.55 and subnetted it with this subnet mask 255.255.255.240, created a whole bunch of subnets, and these three IPs lie on one of those subnets. If I can figure out what the subnets are, then I can figure out which subnet these IPs lie on. That's actually faster than the second way, which is to look at the IP addresses in binary, look at what bits are network ID, and look at what bits are host ID, and then figure out which ones have the same network ID. I'll actually show you both processes, however. So let's start off with the first process. They took 192.168.55 and they subnetted it with 255.255.255.240. Let's see if we can do that. 192.168.55. I'll write out the last octet in X's. 1, 2, 3, 4, 5, 6, 7, 8. They used a subnet mask of 255.255.255.240. Now, from all of the exercises we've done in previous lessons, it should be drilled into our brain by now that 240 is actually 4 ones, 1, 2, 3, 4, and 3 zeros. So when we take this subnet mask and we superimpose it on this IP address, 255.255.255 is covering the first 3 octets. This 240 is covering these 4 bits of the last octet, and the last 4 bits are being left over for host ID. The subnet bits are therefore these 4 bits. Now, to work out the different subnets, all I have to do is figure out what is the increment value. The increment value is the subnet bit with the lowest value, which is this bit. What is that bit? This is 1, 2, 4, 8, 16. This is 16. 16 is our increment value. So what I'll do now is I'll simply work out the new subnets using my increment value. So we have the original network ID 192.168.55.0. The next one will be 192.168.55.16. The increment value is 16. The subnet bits were taken from the last octet. We're incrementing the last octet by 16. 192.168.55.32 is the next network ID. 192.168.55.48. 32 plus 16 is 48. 192.168.55.64 is the next network ID. Let me just flip back here to our IPs. The IPs we were interested in are 60, 63, and 65. I can actually stop right here. 60, 63, and 65. Let's take a look at where those lie. You can actually see it quite clearly. 48 to 64 has 60. So in the middle between 48 and 64, we have 60 and 63. And then right after 64, we have 65. So 60 and 63 are on the 48 network. 65 is on the 64 network. In fact, by doing it this way, we can actually see a couple other things here. If the network ID is 64, 63 is actually the directed broadcast IP for the 48 network. 65 is the first valid IP address for the 64 network. In any event, I've answered the question. 60 and 63 are on the same network. 65 is on a different network. The other way we could have approached this problem is we could have written out the last octet in binary. 192.168.55. We take 60 and we convert it to binary. Now, if you have a calculator, you might say to yourself, well, this way is probably faster than the previous way I showed you. However, if you're in an exam like CCNA or Network Plus, you don't have the benefit of a calculator. So if you were in those exams and you had to convert 60 to binary, you actually had to do some math here. I'll do the math. 60 divided by 2 repeatedly. 60 divided by 2 is 30. Remainder is 0. Half of 30 is 15. Remainder is 0. Half of 15 is 7. Remainder 1. Half of 7 is 3. Remainder 1. 2 into 3 is 1. Remainder 1. So 60 in binary is 1, 1, 1, 1, 0, 0. How many bits do we have here? 1, 2, 3, 4, 5, 6. So I need to pad this with 2 zeros, and there we go. What do I have here? This is 32 plus 16 plus 8 plus 4, and that should be 60. The subnet mask 255.255.255.240 has 4 ones in the beginning of it. Therefore, it's covering these first 4 bits. When you convert a number into binary and you get less than 8 bits, this is why you have to pad the beginning with enough zeros to get your 8 bits. If I had not put these 2 zeros here, I might have mistakenly thought that these 4 ones are my subnet bits, and they're not. Those are not the first 4 bits of the last octet. These are 0, 0, 1, 1. So what I have to do is I have to do this process for each one of these IPs. 192.168.55.63. What is 63 in binary? Again, I would have to divide this out if I don't have the benefit of a calculator. Now, I'll use a calculator at this point because I think you get the idea of what is required. In the calculator in Windows, I'll click on View, Programmer. I'll punch in 63, and right here we see the value of 63 in binary. It is 2 zeros and 6 ones. 1, 2, 1, 2, 3, 4, 5, 6. The subnet bits are the first 4 bits, so there we go. So this has the same network ID as 60. 192.168.55 is the same, and in the 4th octet, the first 4 bits are the same. It's 0011 for each one of them. So 60 and 63 are on the same network. What about 65? 192.168.55.65. 65 in binary. Again, I have the benefit of a calculator. In the exam, you would not. 65 is 0, 1, 0, 0, all the way to the end, which is 1. So 0, 1, 1, 2, 3, 4, 5, and that's a 1. So this is 1, 2, 3, 4, 5, 6, 7, 8 bits. The first 4 bits are our subnet bits, and they are not the same as the other 2. They are different. So 60 and 63 are on the same network. 65 is on a different network.